Welcome back. Today, we are cracking open the black box of AI to really get a look at the engine inside. You know, the computer brains that power pretty much everything, from the camera on your phone to self-driving cars. We're talking about neural networks, so let's get right into it.
I mean, just think about that for a second. What if you could actually do it? Build a system that doesn't just blindly follow instructions, but learns, recognizes patterns, makes connections, all on its own. Inspired by, the most incredible computer ever created, the one right between your ears. That's the amazing idea we're going to unpack today.
All right, but before we try to build a new brain from scratch, we've got to do a super quick refresher. In our last explainer, we talked about the different ways a computer can learn. You can kind of think of them as different teaching methods for our AI student.
Right, so we had learning with a teacher, learning all by itself, and learning from trial and error. But here's the thing. Those are the teaching styles. Today, we're focusing on the student. What's the actual structure, the thing that's doing the learning?
And that question leads us straight to the heart of modern AI. It turns out the most powerful kind of learning happens inside a structure that's directly inspired by that complex web of neurons inside our own heads. This is the core of what we call deep learning. So here it is. A neural network is basically a computer system modeled after our brain. The big idea isn't to program a million if this, then that rules. Nope, it's to build a system that can look at a massive flood of data and teach itself to find incredibly complex patterns.
Okay. I know the whole computer brain thing can sound a little out there. So for the rest of this explainer, let's use a much simpler analogy. Let's forget about the brain for just a minute, and instead, let's picture a super organized, super efficient factory assembly line.
So any good assembly line really has three main stations, right? First up, you have the input layer. That's where all the raw materials, in our case, data, get dropped off. Then you have the hidden layers. Think of these as a whole series of workstations with specialist workers at each one. And finally, you have the output layer, where the finished product rolls off the line. So let's see this thing in action.
All right, now we're going to follow one little piece of data as it makes its journey down our AI assembly line. What's our raw material? Just a simple digital photo. And our goal? To have the assembly line figure out what's in that picture.
Okay, so everything kicks off right here at the input layer. The network doesn't see a picture of a dog or a cat or anything. It just sees a giant grid of raw materials, thousands and thousands of individual pixels, each one just a number representing a color. At this point, it's really just a meaningless jumble of data.
Now that data moves to the first stop on the line. The workers, or neurons, in this first hidden layer, they have a really simple job. They're not looking for a dog. They're just looking for the most basic patterns you can imagine. Straight lines, simple curves, sharp edges. That's it. Each worker just flags the simple little shapes it finds.
Okay, let's move down to the next workstation. This is where it gets interesting. The workers here, in this second hidden layer, they take the simple lines and edges that the first group found, and they start putting them together. So one worker might see a curve next to a line and go, hey, wait a minute, that kind of looks like an ear. Another one might combine a few different shapes and realize it looks like a snout. You can see how they're starting to build complexity.
So after passing through maybe several of these specialist stations, with the patterns getting more and more complex each time, all that information arrives at the final stop, the output layer. This station looks at all the combined features that have been assembled, the ears, the snout, the fur patterns, and it makes a final call. It delivers the finished product. A confident prediction. It's a dog.
So there you have it, our AI assembly line. It starts with a meaningless mess of raw data, passes it through all these specialist workers who find simple patterns and build them into complex ideas, and at the very end, it delivers a finished, understandable product. It's this beautiful, organized process of building understanding from the ground up.
Now this all sounds pretty clever, right? But it leaves us with one huge question. How in the world do the workers on the assembly line know what to look for? I mean, who trained them to spot an ear or a snout to begin with? This, my friends, is where the real magic happens. And here is the secret sauce to this whole thing. We don't tell the workers what an ear looks like. We don't program them with the rules for snouts. Instead, we just show the network thousands and thousands of examples. In this case, tons of pictures of dogs. And through trial and error, it literally adjusts its own connections until it teaches itself which patterns actually matter.
And that ability, the power to teach itself, is the absolute game changer. It's what makes a neural network totally different from a regular computer program. Think about it. You can never write enough rules to describe every single dog or cat or human face in the world. It's impossible. But You can build a system that learns those rules all on its own. That is the engine of modern AI.
So we've got this incredible self-learning assembly line. But does a factory that's built to recognize photos work the same way as one designed to understand human language? Or one that's supposed to play a complex game? Well, it turns out there are all kinds of specialized versions of this assembly line for different jobs, and we're going to meet them in our next explainer. See you then.